Welcome to Share My Lesson. In this video, we will be looking at the 2024 Australian Mathematics Competition Intermediate Division Solutions. Please check the description below for more information. Now, let's move on to the solutions. The larger of the numbers less than 14 is 13.84, and the smallest of the numbers greater than 14 is 14.14. The latter is closer, which means the answer is C. We can use the distribution law to solve this question. As you can see, we get 100 times 346, which gives 34,600. So the answer is D. The angles in any four-sided shape add up to 360 degrees. Using this information, we can write an equation for x as follows. We can evaluate this to find that x is equal to 70 degrees. So the answer is D. Let x be the unknown number. Since the sum of x and 2024 have an average of 2.5, we can write an equation as follows. We can cross multiply and rearrange this equation to find that x is equal to negative 2019, which gives the answer B. As you can see in this diagram, we can section the shape as follows. Then we count the number of squares, which is a total of 9. This means the answer is C. As you can see, P, which is 12% of 300, is 36, while Q, which is 6% of 600, is also 36. The question asks the difference between P and Q. Since they are both 36, the difference is 0. This means the answer is A. Let 0.6n be equal to 17. We can solve this to find that n is equal to 28 and 1/3. The closest integer to this is 28. This means for any n up to 28, the value of 0.6n is smaller than 17, which means that the largest such integer is n equal to 28, which gives E. Let one batch of pancakes have a man's as in the recipe. He has enough eggs for 6 batches, enough flour for 8 batches, and enough milk for 5 batches. So after 5 batches of cookies, he runs out of milk. To find the number of flour he has remaining, we just have to minus 2 by 5 times 0.25, which gives a remainder of 0.75 kg. This is equivalent to 750 grams of flour left. This means the answer is E. Let one container have 4x dinosaurs. This means that the other has x dinosaurs. He moves 18 to the other container so that the two containers have the same number. Using this information, we can write an equation as follows. We can solve it to find that x is equal to 12. The question asks us how many dinosaurs there are in total in Theo's collection. In total, there are 5x dinosaurs, and we know that x is equal to 12. which means there's a total of 60 dinosaurs. So the answer is E. Using the segment between A is equal to 1, 1 and B is equal to 3, 1 as the base of length 2, the perpendicular height must be 6 units. So the third vertex, C, is either on the line y is equal to 7 or the line y is equal to -5. Of the points given, only C is equal to 2 and -5 is possible. And since it lies on the perpendicular bisector of segment AB, triangle ABC is therefore isosceles. This means the answer is E. Between any two successive tablets is 9 hours. There are 14 periods of 9 hours between the first and 15th tablets, which is 9 times 14, which is 126 hours. Since 126 divided by 24 gives 5 with the remainder of 6, this is 5 p.m. on the Sunday, that is 5 days after the first tablet. This means the answer is C. (202 to the power 4 is between 300 to the power 4 and 200 to the power 4. As you can see, we can write these numbers as powers of 10. This means that 300 to the power 4 is 10 digits, and 200 to the power 4 also has 10 digits. So 202 to the power 4 must also have 10 digits. This means the answer is B. The area of a sector of radius r and angle theta is pi r squared times theta on 360. We can apply this formula for A, B, C, D, and E as follows. We can write all their areas with equivalent denominators. This gives that B, which has an area of 25 on 9 pi, as the largest. This means the answer is B. In 30 minutes, Kate will jog 5 kilometers while Jim will walk 3 kilometers. So Kate must have turned at the end of the beach and met Jim on her way back, traveling an extra 2 kilometers. So they met 1 kilometer from the end of the beach, and the beach is 4 kilometers long. So the answer is B. As you can see, we can draw a diagram as shown. The angle at the center is equal to 360 degrees. However, one of these triangles is actually 1/10 of the shape. So 360 divided by 10 is 36 degrees. The other two angles are both 45 degrees. Since the angle in any four-sided shape adds up to 360 degrees, we can write the following equation. We also know that x plus y is equal to 360 degrees. This means that equations 1 and 2 are equal. We can equate these equations and solve for x. We find that x is equal to 126 degrees, which gives the answer B. Of the 18 equally probable pairs, only 2-1, 3-1, and 3-2 have player 1 winning. So the probability that player 1 wins is 3 on 18, which simplifies to 1 and 6. This means the answer is C. We can write some of the possible numbers as shown. We find that all of these numbers have a common factor of 201. The prime factorization of 201 is 67 times 3, which means that 67 is the only two-digit number that divides all such numbers. This means the answer is E. Let the length AB be equal to x and AC be equal to 2x. We can use Pythagorean theorem to find that CB is equal to root 5x. Due to the common angle at C and the right angles at A and M, triangles CAB and CMN are similar. We can use some of the properties of similar triangles to find the ratio of areas as being 5:16. This means that the answer is E. There are 10 data points on the original scatter plot. So the vertical median line passes through the average of the 5th and 6th people values. Likewise, the horizontal median line passes through the average of the 5th and 6th devices' values. It just happens that in both measurements, the 5th and 6th values are equal. This is why each median line passes through at least 2 points, rather than halfway between 2 points. When a new data point is added, there will be 11 points in all, so the new median lines must pass through the 6 people and device values respectively. The 6th value in the new dataset will be equal to either the 5th or 6th value in the original dataset, depending on the location of the new data points. But since these values are equal, the location of the new data points is actually irrelevant and neither median line will need to move. So the answer is B. Listing the numbers in order, we get groups of 6 with the same first 2 digits. The 42nd number will be the last number in the 7th row in this pattern. The 7th row consists of numbers starting with 24. And the last of this group is 24,531. This means the answer is D. The calculation depends on whether the cube is fully immersed. To decide this, consider the volume when the cube is in the tank and it is full to the top of the cube. This is 32,000 centimeters cubed. On the other hand, the volume of water in the tank is actually 24,000 centimeters cubed, which is only 3/4 of the volume required to reach the top of the cube. So the water only reaches 3/4 of the height of the cube, which is equal to 15 centimeters. This is 3 centimeters higher than the initial water height of 12 centimeters, which means the answer is A. On a non-leap year, February has 28 days, so it has 4 of every day of the week. Only in a leap year, when February has 29 days, can there be 5 Thursdays, and only when the 1st of Feb is a Thursday. From 1st of Feb 2024 to 1st of Feb 2028 is a total of 1,461 days, which is 208 weeks and 5 days. So the 1st of February 2028 is Tuesday. Similarly, any period of 4 years this century is 1,461 days, so the day of the week advances 5 days. From a leap year to have a first of Feb on a Thursday requires 7 such advances of 5 days, so a total of 28 years. So 28 years later is the year 2052, which means the answer is D. Let the number of people in room 1 be A, and the number of people in room 2 be B. Let X be the age of the person who goes from room 1 to room 2. The total age of the people in room 1 is 45A, and the total age of the people in room 2 is 20B. After the 1-2 is moves, the average ages are 46 and 21 respectively. So 45A minus X is equal to 46A minus 1. We can rearrange this to find that A is equal to 46 minus X. And 20B plus X is equal to 21B plus 1. This means that B is equal to X minus 21. We can add equations 1 and 2 together to find that A plus B is equal to 25. And also the question tells us that the difference between B and A is equal to 7. We can add these two new equations together to find that 2B is equal to 32 and B is equal to 16. We can substitute this B value into equation 2 to find that X is equal to 37. This means the answer is B. As you can see, we can label the diagram as shown. Next, we can find an equation for X and Y. We find that X and Y is equal to 0.06 and X plus 3 on Y is equal to 0.08. We can label these respectively as equations 1 and 2. We can subtract equation 1 from equation 2 to find that X plus 3 on Y minus X minus 1 is equal to 0.08 minus 0.06. We solve this to find that Y is equal to 150. Now going back to equation 1, we substitute this Y value of 150 to find X. We find that X is equal to 9, so the total tree height is X plus 1.5, where X is equal to 9, which gives a total of 10.5 meters. This means the answer is D. Let A, B, C, D, E, and F be the number of problems completed by each student respectively. This means that A, B, C, D, E, and F are in between 52 and 59. However, none of these numbers can be prime, since the total number completed by each student is K plus 1 times the number completed on Saturday. Eliminating the primes 53 and 59 gives you A is equal to 52, B is equal to 54, C is 55, D is 56, E is 57, and F is 58. For each student, the value of K plus 1 will divide the numbers of problems. Here is a table showing possible values of K for each student. Since each student has a unique value of K, we need to identify one K for each student. Only Daria can have K is equal to 6. So Daria can't have K equals to 3. So Amy must have K equals to 3. This means A, which is Amy, is the only possible solution.
From the C in the thousands digits of the product, We conclude that a is equal to 1. Then we can write the value of each number as an algebraic expression in terms of its digit, as follows. We find that 90 is equal to 9 plus b times 10 minus c. This means that b is greater than or equal to 1, and c is less than or equal to 9. The factorization of 90 in the last line can only equal 1 of 10 times 9, 15 times 6, or 18 times 5. However, the first factorization, 10 times 9, gives a solution that b and c are both equal to 1, which has repeated digits. This means that the second or third factorization is correct. So b is either equal to 6 and c is equal to 4, or b is equal to 9 and c is equal to 5. We can put this back into the equation. 1166 times 4 is equal to 4664. And 1199 times 5 is equal to 5995. Both of these are valid solutions to the puzzle.
This means that we get two valid answers for the three-digit number ABC. These are 195 and 164, which add up to 359. So the answer is 359. To solve this question, first count the number of rods in each pattern. In the first pattern, there are 6 rods. In the next pattern, there are 30 rods. In the third, there are 72 rods. And in the last, there are 132 rods. We find that there's a clear pattern between the number of rods. As you move up in the pattern, the number of rods go up by 24, 42, and 60. And between these additions, there's an addition of 18 between each pattern. As you can see, we can write an equation. 6 plus 24 plus 42 plus 60 all the way to an unknown number has to be less than 2024 rods. We can move 6 to the other side to get this equation. In this sequence of numbers, let x be the last. We can apply the sum of series formula to find that the sum of this sequence is 24 plus x times n divided by 2, where n is a number of terms. We can write an equation for n in terms of x as follows. We get that n is equal to x minus 6 on 18. We can sub this back into the sum of series formula as shown. So we get 24 plus x times x minus 6 as being less than 72,648. We can square 72,648, which gives approximately 270. If you sub 270 in, we get a number greater than 72,648. This means that x is less than 270, but also has to be close to it. We know that x is equal to 6 plus 18n, as the starting number is 6, and there's increments of 18. The closest number to 270 that satisfies 6 plus 18n is 258, where n is equal to 14. We can sub this value of 258 into the sum of series formula. We get a total sum of 1974. If there's another sequence, This number will go over 2024 rods. However, we have to make sure to add 6 to this to account for the starting base of 6 rods. So we get a final number of rods as being 1980. If we subtract this from 2024, we get 44. So in the end, there remains 44 rods. This means the answer is 44. First, let's add 1 to each of these equations. We can factorize them as shown. When we add 1, 2025 prime factorized to 3 to the power 4 and 5 squared. While 729 factorizes to 3 to the power 6. From equations 1 and 2, we get that x plus 1 multiplied by y plus 1 is equal to 3 to the power 4 times 5 squared, which is equal to y plus 1 times z plus 1. We can use algebra to find that x is equal to z. Knowing this, we get equation 3, where x plus 1 squared is equal to 3 to the power 6. This means that x is equal to 26. We can now substitute this into equation 2 to find that y plus 1 is equal to 3 to the power 4 times 5 squared, or 26 plus 1. This means that y is equal to 74. We need to find the sum of x, y, and z, which gives 126. This means the answer is 126. Call the timers A, B, C from front to back. The lamp will turn on when timer A has received 9 hours of power and is starting on its 10th hour. For this, timer B will have delivered 8 hours on his first rotation, then 1 hour on his second rotation. That means he will have completed 1 rotation and be showing 10 o'clock. This means it has received 34 hours of power and will just be starting its 35th hour. For timer C to deliver 34 hours of power, will have completed 44 rotations, which will deliver 32 hours of power. And then another 2 hours between when it shows 9 o'clock and when it shows 11 o'clock. Since C is receiving power continuously, this will be 4 days and 11 hours after the power was first switched on. To convert this into hours, we times 4 by 24, which gives 96, and add it to 11 to give a total of 107 hours. This means the answer is 107. Since 18 squared plus 24 squared is equal to 30 squared, the triangle ABC has a right angle at A. Suppose that the line meets the sides AB and BC of the triangle at the points P and Q respectively. If the length of BP is x, then the perimeter condition implies that BQ is equal to 36 minus x. We can apply the area condition, which implies that the area of the triangle BPQ on the area of the triangle BAC is equal to 1 and 2. We can write this using trigonometry. We find that x squared minus 36x plus 270 is equal to 0. We can use the quadratic equation to find that x is equal to 18 plus or minus 3 root 6. For P and Q to lie on the sides AB and BC of the triangle, we must take the solution x is equal to 18 minus 3 root 6. This means that the length of BP is equal to 18 minus 3 root 6, and the length of AP is equal to 3 root 6. We can apply Pythagorean theorem in the triangle CAP to find that CP squared is equal to 630. This means the answer is 630. We've now completed the solutions to the 2024 Australian Mathematics Competition Intermediate Solutions. Please make sure to subscribe to my channel and check out my blog for more information.